Activity lifecycle. An activity is a screen in your app, but screens come and go. Users navigate, rotate devices, switch apps. Android manages your activity through a lifecycle. Today we understand that lifecycle and how to work with it. An activity represents one screen. When users open your app, they see an activity. They interact with its UI. Each screen in your app is typically an activity. Activities are independent. One activity can start another. They can pass data between them. The system manages activities. It creates them, destroys them, pauses them. You do not control when this happens. The system does. Your job is to respond correctly. When the system creates your activity, set up the UI. When it destroys, clean up. Android calls specific methods as the activity moves through states. OnCreate is called when the activity is created. Initialize your UI here, only called once per instance. OnStart is called when the activity becomes visible. Not yet interactive, but visible. OnResume is called when the activity starts interacting with the user. Fully visible and active. OnPause is called when the activity loses focus. Another activity is coming. Still visible but not interactive. OnStop is called when the activity is no longer visible. Another screen covers it completely. OnDestroy is called when the activity is finishing. Clean up resources. The lifecycle flows through states. Launch, OnCreate, OnStart, OnResume. The activity becomes fully active. Navigate away, OnPause, OnStop. The activity goes to background. Return, OnRestart, OnStart, OnResume. Back to foreground, finish, OnPause, OnStop, OnDestroy. The activity is done. Each transition triggers callbacks. Your code runs in response. Not all transitions are smooth. The system might kill your activity. You must handle unexpected destruction. OnCreate, set content view, initialize UI components, restore, save state. This is your setup. OnStart, start operations that should run while visible. Register listeners. OnResume, start operations that should run while active. Resume animations, acquire exclusive resources like camera. OnPause, release exclusive resources, pause animations, save lightweight state, keep these fast. OnStop, save persistent state. Release resources not needed when hidden. OnDestroy, release all resources. Unregister all listeners. This is your final cleanup. When configuration changes, the activity is destroyed and recreated. Rotate the device, configuration change, language change, configuration change. Dark mode switch, configuration change. The system destroys the activity, then creates a new one. Your activity must handle this. OnCreate is called again. Your UI must reinitialize, but you want to keep user state. This is why state saving matters. The user was filling a form. Rotations should not lose their input. OnSave instant state lets you save state before destruction. Override fun OnSave instant state outstate bundle. Put values in the bundle outstate that put string key value. The system passes this bundle to OnCreate when recreating. Saved instant state is null on first creation, non-null on recreation. In OnCreate, check if saved instant state is null. On recreation. In OnCreate, check if saved instant state is not null. If so, restore your state. Keep save state small. Only save what is needed to restore user experience. Large data should be in a view model or database. You can restore state in OnCreate or OnRestore instant state. OnCreate if saved instant state not null. Restore values. OnRestore instant state is called after OnStart only when there is state to restore. Both approaches work. Choose based on your needs. Most developers use OnCreate. For UI components like edit text, the system automatically saves and restores text. You only need to give the view an ID. For custom state, you save and restore manually. Modern Android provides lifecycle-aware components. Lifecycle Owner and Lifecycle Observer let components respond to lifecycle events automatically. View models survive configuration changes. They hold UI state across rotations. Live data and state flow are lifecycle aware. They only update active observers. These tools reduce manual lifecycle management, less coding callbacks, fewer bugs. We will explore these in later videos. Let us summarize. Activities are screens with a managed lifecycle. Lifecycle callbacks let you respond to state changes: on create, on start, on resume, on pause, on stop, on destroy. Configuration changes destroy and recreate the activity. Save state in on save instance state, restore in on create or on restore instance state. Use lifecycle aware components to simplify management. Respect the lifecycle. Initialize at the right time. Clean up at the right time.